Hello, everyone. Hi, I'm Victor. I'm excited to be here despite the early hour. It's actually 7 a.m. in my country, but nevertheless, I'm super excited to talk about CI/CD workflows for Airflow DAGs. Let me start by introducing myself. So here I am with my two daughters, Mayan and Nom. That's who I am in my spare time. But in the rest of the time, I am actually co-founder of a great team of data enthusiasts, Data and AI. Together, we build a monitoring and alerting solution to help data engineers with their production pipelines. My background is actually machine learning and algorithm engineering. And in the last 20 or so years, I was engineer, researcher, and R&D manager. And that's actually where my interest in CI/CD solutions actually come from. In the last few years, I had these nightmares that I'm sure some of you also had. It usually happens one day before vacation starts or a few hours before the weekend, when you start to realize that your production data pipelines are not behaving as expected. It can be a cluster that is blocked by exceptionally big job, or some kind of production data partition that was accidentally deleted, or it's just a new jar that caused existing DAG to fail. And usually what happens is that it takes a lot of time to discover and fix these issues. And of course, like this is not something that I was happy about, because like, first of all, I don't want to spend all my money on the sleeping pills. And also I don't want my weekend to be ruined. So I started to think about these problems and started to think how these problems can be fixed. And then like I realized that the root cause of these problems is actually the fact that some of the features, some of the extensions of the DAG code or the new DAGs are not tested well enough before they are pushed into the production. And that's how I started to think about this topic of end-to-end testing for Airflow DAGs. So basically, it was about building a robust testing for new features and new DAGs that would include the isolation testing for each and every feature and integration testing for the DAGs before they go into the production. And that's when I realized that CI/CD is needed for my DAGs actually. As like CI/CD is a just to give a kind of context for all this, it's a practice of moving software from the development to testing and production. It's a very established discipline, specifically like in the classic software development. This process is continuous to allow every developer to safely test a new feature and to push it into the production, while automation is actually key for this process to be successful. So CI/CD pipelines are what defines this automation. And our idea was to build these pipelines of data pipelines. So to build these pipelines that allows us to safely move code from the development to staging and to the production. And specifically in this call, I would focus on how we've implemented this piece of end-to-end testing of our DAGs. Last piece of a context, the majority of Airflow workloads are actually like data workloads. So it's data in, data out. And the de facto standard for this kind of workloads is Apache Spark. I will actually Airflow community, the 40% of Airflow community using this kind of operator. And I personally myself very familiar with this type of operator. That's what I use in my day-to-day job. So in this discussion, I will use Spark operator as an example. At the same time, it's important to say that everything that like we will review in this presentation is valid not only for Spark submit operator, but also for different Spark flavors, Spark operator flavors, like AMR step, Dataproc, Databricks, as well as other data operators, and so other data operators in general. So be it Python operator, Docker operator, or any other kind of operator. So let's move on and let's discuss CICD for our DAGs. Here's an example of DAG that implements some kind of business logic, a typical business logic. We start by checking like if we have a fresh data or we need to generate a new data cache. Based on this decision, so we have the branching operator that either generate this data or skip the step. Then we process the data for the 6 partners. We do this processing in parallel, or potentially we do this processing in parallel. And then we have a step, generate report, that consolidates all the data that comes from these different operators into the one report. So this is the DAG, and each and every step encapsulates some kind of business logic. So as I mentioned before, for example, Spark script or maybe Python script. So what do we need to test? The first thing we need to test is the business logic. That's the Python or Java code that each and every operator calls. So one thing that we should do for sure is to test these scripts locally in isolation. So it's a great start and it's an important step to do, but actually it's not enough. We also need to test this business logic in the context of the full graph and make sure and understand how this business logic behaves in a different condition and different states of this different states of our DAG. So for the business logic, we need to do both. We need to do local isolated testing and end-to-end integration testing. Let's review the DAG code. So we have this DAG in front of us. So let's see what can happen and what actually can go wrong. There are a few questions here to ask. First, do we properly create the branching condition? Do we always pick the right path to either generate the data or skip it? Are we able to properly run all these different partner data generation tasks? What happened inside the generate report? Is it able to consolidate all the data from this partner task? What happens if one of the partner tasks failed? Should generate report run in this case? So there are a lot of questions here that are a lot of logic here that is actually encoded inside the graph definition. And this logic it should be tested because it's actually it's a business logic. It's something that that defines how our business logic, how our DAG behaves. So testing DAG structure locally is a great idea. We should definitely do that. It tests the DAG builder, but at the same time, we should also test the DAG end-to-end. We should be able to run it end-to-end, and we should be able to see how different conditions affect the execution of our DAG. So let's continue this example, and let's look at generate report, which is the last operator in our DAG. And as I said, we will use a Spark submit operator. So here's this example. Here's the code that runs this Spark script. And as you can see, this code, has a number of parameters that parameterize this Spark job. So the first parameter to notice is the connection ID. So connection ID is actually cluster selector. Connection is the piece of metadata that is kept in Airflow database. And this piece of metadata allows us to connect to connect to properly configured Spark cluster. So using connection ID, we can actually pick this cluster. Then application and application args define the business logic. So the business logic is a Python script py, and this business logic has 2 arguments, like input file and the output path. So these 2 parameters define the business logic, and we'll talk how to make these parameters support our CICD as well. The last 3 parameters, jar, py file, and driver memory, these parameters are Spark job configuration. So they define dependencies, Java dependencies, and Python dependencies in our case, and they also define the configuration of the memory for our Spark driver. So all this together is what defines the Spark job. And this Spark submit operator is actually instantiated into the CLI, into the Spark submit command that use these different parameters in order to run Spark script. So let's see what needs to be done in order to make this Spark submit operator to support CI/CD. The first thing is to make sure that we allow execution isolation, which means that what happens when we are running at staging, we are running at the same cluster, but we use different versions of dependencies and different version of dependencies and custom resources. So we need to make sure that our configuration, our job configuration, is fully isolated from the job configuration of other jobs. In order to do that, like one idea, one way to do that, that's like we actually implemented, was to parameterize the jar and Python file locations. So here we parameterize our jar name and our Python file with the git commit hash. So now with for every feature, like we will have its own git commit, and this would allow us to parameterize its execution and to make sure that each and every job has its own has its own dependencies and is capable of successfully managing them. So so far so good. Let's move forward. The next thing is actually the data. So data is actually an elephant in the room, because like while Airflow DAGs are all about moving in transforming data, the data management is very implicit within the DAG. So it was hard to understand from the DAG definition that I showed before what is the actual data flow that this DAG creates. But this data flow is actually critical for our CI/CD, because this one is also should be properly handled in our production and staging environment. And similar to execution isolation, we should make sure that our data is properly isolated. So in order to create end-to-end tests for our DAGs feature, we want to be able to run them on various kinds of data. It can be production data, it can be staging data. We want to use big data, small data, maybe errors data, and all this should be supported by our staging environment, our CI/CD. Our business logic shouldn't have any unexpected side effects. Otherwise, these side effects will be global, and they will break the logic of our execution. And again, we wouldn't be able to properly test our features, our DAGs end to end. So all the staging jobs should write their intermediate and final results to the separate areas to avoid collisions. And we also want to keep these results. We also want to keep these intermediate results, because inherently these DAGs are long-running processes. And in some cases, you don't want to run the whole DAG. You just want to run a specific operator. You want to run, or you want to run the part of this DAG, and you want the data. You want the data that's used in order to run these DAGs to be available for you in order to be able to do that. So let's see what we have done in order to implement this kind of solution and allow data isolation. We actually went through a number of steps in order to build that. And our first step was to use the standard features of Airflow, which are the Ginger templating and XCOM. So the Ginger templating is what allows us to create paths, to templatize parameters, to templatize parameter based on the in the runtime of our DAG. So we can create templates of parameters that depends on our DAG ID, run ID, and execution date. That's what you can see here on top of this example. So our prefix, our pass prefix, is actually contains the variable definition. This one would be our staging on production or production environment. Then we will have a DAG ID, the specific DAG ID that is currently running, task ID, and then the execution date, execution timestamp. So these parameters all together will make sure that our passes, the passes that we are using inside our DAG, are unique for each and every run in our staging environment. So here, like we have a snippet, we have a subset of a DAG, right? Two operators, join, which is the Python operator that use XCOM in other Airflow features that allow different operators to communicate. So it uses XCOM to communicate its output to the downstream operator, like actually to communicate its output globally. And then the output operator, which is the generate report operator that we were discussing before, are using XCOM to read these outputs, to read these outputs passes, work on them, and then create a output, create a report that is also prefixed by the same prefix that we were discussing before. So in the context of Python operator, this prefix would include the join as the task ID, and in the context of our Spark operator, this prefix would include the generate report as a part of its pass ID. And by doing this, we will make sure that this run have all its outputs and intermediate outputs in isolation, and we can so it will run successfully, and then we would be able to reuse these outputs later on. So this is a great solution, and it serves us very well. Serves us very well. However, you can notice that there are a few issues with this solution. First of all, like it's very verbose. Like you need to write a lot of code in order to pass parameters between your operators. And the second problem is that this allows a place like it allows you to create a lot of errors, because like it's easy to make errors in this kind of templates. And by doing this, you can not only like fail your job, but you can easily actually fail the jobs that other people are running. So there are like these unpleasant side effects. So the next idea that we had is that like instead of like letting DAG authors to explicitly implement all these templates and use them within the DAGs, we actually can create a library. We can create a library of Jinja macros that would allow our users to do exactly that, to generate unique passes for each and every run within the CI/CD environment. So how we do that? We create our own Jinja plugin, and then we register it within the Jinja framework of Airflow. And by doing this, like we have these macros that you see in this code example. So we can say my company data repo, my company data repository, get artifact, and then just mention the name. And this this plugin would generate the pass that I've mentioned in the previous example. So the pass would include environment, DAG ID, task ID, and execution date, just to make sure that these arguments, to make sure that these arguments are unique and can be used in our CI/CD, in our staging environment. So like what's next? The library of Jinja templates is really good, but then actually, like while talking to DAG authors, to people who are writing this code, we also like came to realize that that the existing Airflow operators and the regional Airflow operators, what they are handling is actually execution layer of operator. What if we can create our own like custom operators using standard Airflow hooks, and these custom operators would be capable of implementing the full data management layer on top of existing Airflow operators. This is like an interesting approach, because in this case we will have we implemented this kind of ideas, and so we have a full control of what actually happens in the data layer management. So we can do everything that I showed in the previous in the previous two approaches, but we can do much more. For example, I mean, we can test for availability of inputs and outputs before we run our operators. We can actually even serialize our outputs automatically. And using this, like another idea that can be implemented is the automatic wiring of the task, because the moment we know that this generate report task is using the output of our joint task, we don't need to specify explicitly upstream downstream dependencies. We can do it automatically inside our code, inside our custom operator code. By having full control over the inputs and output separators, it actually allows us to do a lot of stuff and to make the life of the DAG authors much easier. So because everything is fully automated for them. So by using this, like these three approaches, and we were building these approaches gradually, we were actually able to achieve a lot of things. Because now, like you can actually do a lot. You can run iterations on your CICD, and you can do it easily. And while doing that, you can use any data inside your iterations. So you can run with production data, you can run with staging data, you can generate data that will help you to do regression testing or stress testing. I mean, you can even implement some like ideas around like chaos monkeys for your data, because now it's easy to kind of inject different data into your DAG and see what happens. It was like this approach also made us possible to use the same cluster for different versions of DAGs or for different features within the same DAGs, which also simplified our deployment a bit. And what probably was the most important, and I'm personally is super excited about that, is that we actually allowed our end users, our DAG authors, to run this regression testing. So it's not all like it's not only us, it's not only like engineering team who is now running these regressions. Each and every one who implemented his feature is capable of running his regression, and actually capable of even running multiple regressions if he wants. So we have a full suite for end-to-end testing for everyone who is working on our DAGs. And this is actually a lot. This is what simplifies the work of the people. That's what reduces the overhead. And that's what allows people to focus on the business logic, on the stuff they know, or the stuff they like know how to do and feeling like mostly comfortable with. So recently, there is a lot of work in the community that actually goes around the same ideas. So I do want to mention a few of these works, because the community in general, the way I see it, is now also thinking on how the more and more like data awareness can be brought into the Airflow. And one great step in this direction is actually AIP31 that was recently recently merged into the Airflow master. So this AIP is actually talking about really simplifying the handling of the kind of templates and kind of XCOM arguments that I was talking about. So using this AIP, using these features that this AIP introduced, it's much easier to introduce this kind of templates and this kind of ideas into your workflows. And actually, there is more work to come. There is more work that happens on data lineage and on data awarenesses within the community. And we are data band, us as a company, and we're really looking forward to continue and contribute to this work. Last piece of the reference that I want to mention is our own implementation of the ideas that I was talking about. DBND Airflow, it's the open source project that implements the data management of our own. And I do encourage you to have a look at it. It's a GitHub project. You can Google it and look at it. And as I said, it implements the ideas that I was talking about. And we are looking forward to actually implement more and more of these ideas into bring it to the standard Airflow. It's probably time to recap like what we discussed so far and what we went through. So like first of all, like I gave this example of data intensive DAGs and the kind of problems that we faced, and like from also talking with our current customer, like our customers are facing. So we I can kind of build the motivation why we need to build the CI/CD for our data DAGs, for our data intensive DAGs. Then I used the Spark operator as an example to show how we can build effective CI/CD for Airflow DAGs, what needs to be done, what needs to be parameterized, and how this can be done. And then the next step was to actually take this idea to the next level and to talk about more and more data awarenesses within the Airflow DAGs and the level of control, the level of data management that can be implemented on top of the ideas that I have presented in this talk. There are a few topics around CI/CD that I'm personally very interested in, but I wasn't able to talk about them. Like I really hope to be able to present this topic in the next Airflow summits. And these topics, this like actually, and I want to mention like two of them. One is how the DAGs can be deployed, how the deployment between different environments is actually working. It's a huge topic, and it's definitely worth the separate lecture. And the second topic that like I'm personally like very involved in is the topic of moving DAGs from research to production. As I told you, like my background is machine learning, and like I see a lot of research work, a lot of experimentation work happens. And unfortunately, in many cases, this work happens without people using DAGs. So people are just using tasks, using some business code that they are running in isolation. I do feel like it's a big problem. I do want, like, we do work with our customers on how these problems can be fixed. So I personally very interested in the streamlining of research DAGs into production. What needs to be done? How this can be done so both the data scientists and data analysts are happy and data engineers are happy. So I really hope to be able to talk about this topic in one of the next Airflow summits. Before I finish and like give some time to the questions, I want to promote the two talks that my co-founders will be doing. I really like encourage you to go and hear that, because we are working with a lot of customers that are running their Airflow, that are running the Airflow, and we have collected a great deal of experience with working with Airflow DAGs and especially with data DAGs. And these two talks would be talking about how bring more data awareness and more data visibility and data observability into your Airflow DAG, and I really encourage you to join them. Thank you, and I think it's time to go to the questions.
Sorry for the technical interruption there. So a very big thank you to Victor for his insightful talk on building a proper CI/CD cycle in production. And let us move on to the questions. So I think we don't have any questions from the audience. So I will like to take this opportunity to ask the audience if you have any questions to ask Victor regarding his given talk, maybe his experiences, the difficulties he faced. I would like to ask you to share your questions with us. Seems that we don't have any questions from the audience. So if it is okay, I would like to thank Victor again for his talk on creating these CI/CD cycles using Airflow, and also the organizing committee.
Thank you.
And The next session will start at 2 p.m. Japan Standard Time. Okay, there is one question from audience before we just move on. What CICD platforms would you recommend?
Yeah, I think like it's a good question, and I think that in like first of all, like in general, the area of like CI/CD tooling for data pipelines, I think it's like undeserved, and it definitely requires like a product of its own. But what we have seen so far, and that's what we actually doing, is that we're using existing GitLab or GitHub CI/CD pipelines to implement like this kind of solutions. So it's the standard, the standard GitLab CI/CD pipeline would be very useful. Of course, like Dockers and Kubernetes would be also part of this infrastructure. But using this, using like Airflow, GitHub CI/CD pipeline, and Kubernetes, like would be the right tool set to implement this kind of solution. That's actually what we did in our case.
Okay, so a recommended platform would be using GitHub with using GitHub related technologies and combining with Kubernetes. So thanks a lot for the question and for the answer. And I think that's all the questions we have. And let us once again, thanks a lot, Victor, for his great presentation. And the next session will start at 2 p.m. Japan Standard Time. And the next session is production Docker image for Apache Airflow given by Jarek Potwick. I think I pronounced his name properly. Okay, so there is another question coming up. Okay, Victor. The question is, what was the relative balance of your use of Python bash operators versus custom operators?
Yeah, like in our case, we actually like we are heavily on Spark. So we are heavily on Spark, and we're using we are using like the Spark submit operator, as well as like Databricks and the EMR Spark operators. But I would say that like it's like 60% of what we do would be like different flavors of Spark operator, while 40% would be Python. We usually not writing the like pure bash operators, and but like as I said, like on top of these two, we have our own custom operator implementations that are implementing this like data management layer that I was talking about. And this data management layer is actually work for both Python and Spark.
Okay, so 60% Spark Shell and 40% Python-based scripts. Okay, thanks a lot, Victor. So
thank you.